So, hi all, we can start today's session.
Good evening, all. Welcome to the final day of our virtual SolveWork workshop. Once again, I am delighted to introduce our esteemed speaker, Mr. Anjan Kanakillam. He is a certified SolveWork professional with extensive industry experience. In the previous session, Mr. Kanakillam provided a comprehensive introduction to SolveWorks. He had covered the basics. His expertise and guidance have equipped us with a solid understanding of the software's fundamental concepts. Today, we have the privilege of continuing our learning journey with Mr. Kanakilla. In the session, we could learn more about SolidWorks. Over to you, sir.
Okay, let me present my screen. Hope you can see my screen. Okay, so as we discussed yesterday, so today we can go a little bit faster. If you feel like if you are not understanding any time, please turn on your mic and you can ask me to slow down, or yeah, you can give any doubt, or you can ask anything. So as I told you, when we open the SolidWorks, we will have this slide. And yesterday, what happened? Like yesterday, when after drawing that model, the base, I forgot to save, so it's lost. So I was planning that I draw it. Means I tried to draw it completely. So I'm planning to design it from scratch. This time I will choose, as I told yesterday, we have different ways to approach this problem. So yesterday, we we did one method. We first made a rectangle. I believe you can remember, and we extruded it. Then we took one face of the rectangle, and we did make two squares and one rectangle, and we used extrude cut to make this base. So today we are avoiding that extrude cut. We are directly going with single extrusion, which will result in the base. Okay. So same as yesterday, sketch is the first step when we are going into this drawing. Choose any plane. You can choose any plane you wish. For me, I feel I go with right plane. So this time, I yesterday I will think you remember that I have chosen rectangle. Today I go with line. So we can just um, draw half of the base. It won't look like half of the base because the dimension is not correct. Let it be like that. So I think you could see that like both these colors, like background colors, are same, which means this is not a um, closed what to say area. Okay, so for extrusion, to, like for 3D conversion, we need a closed area. So for that, we should connect this. For this is as this is a simple drawing, we can understand. Oh, here we have like break. So we click here. So we have multiple options. We can drag here, or as I told you yesterday, we can click both points and give a relation. Like there are multiple relations. We can go with here we have the relations: horizontal, vertical, coincident, merge. As in the case of this 2 points, both coincident and merge will be same. I go with merge. So when I click merge, uh, like you could see that the colors, like this has become a little darker, which means it's a closed area. And you can see that this we have blue lines, which means it's underdefined here. In bottom we can see it's underdefined. Other thing you should notice when you start drawing is hope my mic is on. Okay, okay. Is the unit. Just confirm it, as it is like mmgs. Yes, since our drawing is in like we could take anything. Nothing is mentioned, so we can take any unit, but we as standard we go with mmgs. So it doesn't look like our base. So what to do? Like we have to go with this is 12, this is 12, this is 10. We can see from the drawing, from the picture, and this whole is 100. That means half would be 50. So like here 150, it's easy. So that's why I yesterday told you to keep a book with you, so that sometimes little simple calculations will be coming, just that you can just note down. Sorry. Then half of 52, we can go like give 26. So everything is half because we are planning to draw half of the drawing. So like we need not to go every time. It's like wherever we symmetry comes, like we can just draw the half of the drawing, and we can use yesterday's principle, mirroring. The principle be like at the end we conclude as yesterday's session was mirroring. So here we can use mirroring because everywhere where there is symmetry coming, we can go with mirroring option. So before going to that, we need to define uh, this is 12, 12, and this is 24. So okay, I'll go. This is 10. This is 26. This line and this line is 50. Okay. Then this is 12. Like this, okay. Before doing that, like we have to make this square, right? So I just take this and this and give it equal. I think you have like, you remember yesterday's equal relation. Here we can use that. And I forgot to give this 12. So when I gave here 12, like you could notice there is an error message, not error message. They like they're showing that it's an unwanted dimension because, of course, if this is 24 and this is 12, it means this is 12. Like need not to give it again. So they are telling it's an unwanted dimension. So we can close that. So now it's fixed. So sometimes still it may be not fixed because like we gave every dimension, still it won't be fixed. That time you check whether the position is fixed or not, like with respect to origin, like that. So since I gave this line and this line uh, is like this is vertical to, means to origin, and this is horizontal to origin, so it took that relation to make this as fixed. So we can go with our extrude option. We can. So this is now coming in this direction. I don't want it in front. I want it in back. So I can click here. Like you like just notice wherever my mouse goes, because like means I will be clicking in options, like many options. So go like your eyes should be on my mouse. So here just adjacent to this blind option, we could see the arrow. So we can click this and the like this direction reversed. And if I could remember, like I can share you this drawing, or you can just take a screenshot of this. Okay, like if you want to just start this drawing. Okay, this is 160. Here we go. 160. I can give mm, or like I got a centimeter. If it's a centimeters, uh, I can give 1.6 centimeter. Sorry, 16 centimeter. Like it took, like it understood that we are giving centimeter, but we need it in mm. Like we need to show in but like our calculation is like if you take inches, you not need not to make do calculation and change it to or like that. You can give in inches, no issue. The SolidWorks will convert it into no issue. So just click done. So we are half of it. Now we need to create the next half. So here, like yesterday, we took the mirror here. Like this is mirror for 2D diagram. Okay, when we come here, we can see this description coming. It's for 2D diagram. Here in features, you could see many options. Here, there is one called mirror. Click here. It will be asking mirror face or mirror plane. So we have to mirror to this plane because we need close adjacent, like we need to be its continuation. Click here, phase one selected. Now they are asking like what features we have to like features, or should we they are asking whether like we need to just mirror this faces, just faces. No, we need to like we need a solid body, so we need to mirror the body, complete body. So like there are multiple features, you need not select all these. You go here, click here, and here you could see there are multiple options. Let it be default at first, then when you like do more drawings you will understand. But the one thing you should remember is put this merge on. Like if you like, I will show you. I click here. Okay. uh Here I think like we can see no, there is no separation coming because it's a single body. So once we have like I mirror, like I did this mirror option, and yesterday I forgot to tell you this. Now I'll give you that that thing. That is like once we did something, extrusion, we did extrusion, we did mirroring. Here we have like the tree. So here we can click on the mirror and click on the mirror, and here we have the edit features. So we thought like we need not to create single body. We can untick this and tick. So here we can see that like when we select one here we have two bodies, separate bodies. Since we didn't tick the merge option, we have two completely two different bodies. But it is like adjacent to like it's close to each other since we gave a mirror option to that face. It's adjacent, but it's not same body. So here we could see that solid body number two. We have two bodies, one body, two body. So since here we like we couldn't see any separation, we'll go with single body. So again, edit feature, merge solid, done. You can edit the extrude first extrusion. You can go change this 160 into like if you did any mistake, or if last minute any updates comes, you can come here and edit. So this is like where we stopped yesterday. So today I showed you different way to approach this problem. Now there are also like there could be another feature way to approach this problem or approach this design. That like you when you are drawing, you will understand. When you draw multiple times, when you do some of the drawings, like some of the design, you will understand like, oh, you can do this. And when you are seeing somebody drawing, so we'll understand how they are approaching the problem. Now you saw the two methods. Now when you of course you will find many people designing, so their approach will be different. It won't be like mine. So you will learn that, and you can take which is more simple or which consumes less time, because at last the main thing is you should design it fast, accurate. So next we have to build this dome, or what you call, yeah, this structure. So we we take sketch again, and now I was planning to draw in this front plane or the mid plane which is coming here. So for that, you like, I lost the tree here. You will now, since I click sketch option here, I lost my tree here. So here you have a option here which could, like, clicking here you could get the tree. So I go here. If you don't remember which plane you have to draw, you can just go here, front plane, top plane, right plane. It will show the preview. So for me, I need front plane. So I'll draw this side. Okay. Again, line. I need a vertical line. Yellow signal showing vertical. Yes. Then I, like, you saw, from here still line was coming, so I pressed escape button in my keyboard. It's gone. Then uh, then I have to draw a second line here. I have to make this same, equal, equal. Then one thing, like, you can do is you can draw a circle and cut it. I'll show you. Or you can directly draw an arc, but I'll show you how to cut. So I need arc here, like a semicircle, not an arc. Of course, arc, semicircle is an arc, but I need a semicircle here. But I, like, took a circle. Then, like, I give it as, like, this and this circle as tangent. Tangent, yes. This and this line as tangent, yes. Now I want this point and this circle as coincident. I mean, I want to, like, touch it. Okay, done. So I need not want this part of the, like, I need to, like, when we are drawing in our um pen with using pencil, we have eraser to rub, or we can, like, remove the unwanted lines. Here we have the option called trim. Trim is used to, like, if you have, I will show you. If you have a line, I want to cut it from here, like, I want to cut it from here. So what I do, I draw a second line. I want to remove, like, this is the main line, and I want to remove this part. So what I do, I took take trim option, and I can just, like, just draw. So we can just draw, and the line is gone. If I want this line also to be gone, I can draw like that. Like that, I can, like, remove, or we can call trim. That's a trim option. So delete, delete. So here I have to trim this part. So I draw, it's gone. Still, if you could remember, like, first thing I told, this is same color. This means this is not a closed area. Since I have to extrude it, I need to be closed area, because this part is not closed, because we have a, like, base, but this is not part of this drawing. So that base is different. So I have just connect these points. Done. And I have to give the dimension, which I believe it's like I think you all have gone means like what to say, have took your graphics classes. So if not, this R means radius 30. Okay, I think like most of you have attended graphics, but still, if you are very new, this like I could that's R means radius. Okay, I give 60 since we need a diameter there. Done. And I have to give this height. It's giving us 42. So this is 42. This point to this is 42. So as per yesterday, I can draw it. I can extrude it. Then I can again draw a circle and I can cut through. I means do extrusion cut and remove it. So, but like today I introduce a new method. You can like you can go with what you want in first time itself. Like we can draw a circle and we extrude only the part we required. So here I draw the circle and I give the diameter as 30. So it's showing like different shades because this is a separate closed body. So if I go here, I need to extrude. Okay, it's showing us blind. I don't want blind. So yesterday I just explained you about surfaces, extrude to surfaces. Uh, s- so here we can like we can go means I don't remember like what is this diameter length. So I can go extrude up to surface. Then I need till here. I think image it's visible. The extrusion happens from here to here. I need till here. So when I click the surface, see we can see from the side that the extrusion happened till this distance. I didn't give any dimension because I don't know and I need not to know the dimension. I just like my like I was given a drawing. I just want to draw it. I need not to like um understand each and every dimension. It's good. Like I just need a perfect drawing. So I don't want to calculate it. So I took the surface done. Or other option is uh sorry. Other option is you can go extrude. You can give as a multiplane. There you need to give the dimension. Like multiplane means or else I should I had to mirror it again. So here I expect this is more simple option. Like I showed you that option too. Like in any other different problems, when you do, you can use that up to surface option. Here I believe this mid plane is the best option. I mean, is the like best way. So since we are using plane, we have to know the distance. It's given us 76. We go here 76 mm or just 76 is enough. Done. Okay. Now I have to make this arch. This what to say ramp. So again sketch front plane. So uh, I draw from here. This is edge, and I know this like it's if you could see that it's tangent to this surface circular area. surface, circular surface. So, like when we come here, it's showing in blue, sorry, in yellow that what to say, tangent coincident area, this option. So you just click there. It's now like tangent, and it's touching this curve. We have to extrude. For that, again, I'm saying we need a closed area. So one option is I can draw here. I can draw, and I have to draw this arc. It's like again a task. Means it's an again what to say, extra work, or we have another option, like we can convert this, like we know that our line should go through this plane, and this plane, and this plane also. So we can take this like this view, and take this convert entity option. Click here, click this line, click this line, click this arc, click. So here like if you could zoom in, you can see a line. So what will convert entities do is it will um, it will take the entity. Here we took edges, like we took the edges, and it will project that edge or entity into the plane we are like we are doing the sketch. So here we are at present we are in sketch 3, which is on the front plane, I guess. Yes. So it will what to say, it will we have a line in the front plane showing this like it's this entity is now projected into that plane as a line. Of course, in a plane it will be everything will be projected as a line. Then like then I need not need um this part. So I trim. So this line is can extend here. So I just give this and this as merge. Now I give this tangent. Done. It's now a black line. Now we are ready to go. So ready to go with the feature. Same, my mid plane. We not we need only 12 mm. We go with 12. So the body is ready. And I believe these all are like what we say, little more. I can't say it as a complicated. Uh, this will be required uh, like specific uses only. We need not to use every time. The features I have shown you now, it will be mostly like these features are mostly used for every drawing you design. These are the basic features. Sorry, these are the basic features you use, and these are like shell option. I think shell means, of course, hollow inside, which means uh, like if you take a ball, football, it's a hollow inside. So it's a shell. I'll show you what happens when we shell an object. So I will show you some more features here. Like here we have, if you zoom, like if you do some zoom here and here, and we not need to get back to that zoom fit option. Here we can do this, And if you like click this, and if you want a particular area to zoom in, you have this option. Again, go with this. This is a previous view. Like we viewed this and we need to go back to that view. You can go with to this previous view. This is section. Like we can view it in a section view. Like this is a plane. This will slice, and we can get that like what's happening inside. Here it's symbol drawing, so we can expect this. This is what happening. So we can see that this is what we are getting. So at the mid, we will be getting this. Uh, this is how it will be in middle. So if I go with shell, I click this plane. So this face means what happens is this will make this entire body as hollow by making this face, the face we selected, open to like open to it will remove that face and make this complete thing hollow. Here we can give the like we can give the like thickness. I give as 2 mm and done. See, you can see that shelling has happened. And so now I need similar to football. Like we can't see it's hollow, but it should be hollow. For that, we remove this face. Just give shell. Now it's hollow from inside. But how can we know? That's why I showed you this features section. So when we cut it, we can see. Similarly, when we cut the football, we can see it's hollow from inside. Else, like of course we can guess, but just a view. Don't take football. You take a like a like sphere. You can't say it's a it's a solid or a hollow without cutting it. So now when we cut, we could see that it's hollow from inside. This is a section feature we can use. Now, I don't want section. I want a solid body. Here we have a delete option. Or like um or assume a case where uh we'll be in a confusion whether we want a section or not. But at present we don't want a section. In future, I can go with section. So I can just suppress it. So it's not a like a shell, but there is shell option available. We can just at present it's not a shell, but if you want shell later, we can just unsuppress. Since I don't want section, I just delete it. And when we are drawing, of course, these are all like we should give a material. So we can see that here they are asking material. It's not specified. We can click here, right click here. So we can when we right click, we have a number of options available. Mostly used parts. So we have plain carbon steel, cast alloy steel, ABS, then cast iron, aluminum, brass, copper, general purpose material, nickel, rubber. But if you want more material, you can just click edit material. There are n like lots of material, and you can make even custom materials. But if you take custom materials, you should know these properties. You can search for the properties of metal or even plastic or anything, and you can select a suitable material for when you are designing a new part. You can take materials from here by taking like elastic modulus, Poisson's ratio, tensile strength, yield strength. Similarly, every features you can take. So here I go with the plain carbon steel. So the color changed. Like some of your laptops may not show the similar color. It may differ. It may be different. Like if you have a good processor, it will show like this shiny features. Or like when I was using my old laptop, it doesn't show, there was no shiny features available. When I give a plain carbon steel, it will show the similar color, or it would be dull color. It works like if you have a high powered laptop or high powered computer, it will show a beautiful like it will like we will feel it as pure metal. So it's my current laptop is okay. It's not a pre like high class, but it's okay. So it's showing okayish image. Okay, now we can go with one more thing, and then we go with assembly. Uh, then yeah, fillet. When we are fillet means like when you are designing your designs from your mind, you need not you will be thinking of I need don't want the sharp edges. I need a smooth, like what to say, a curve there. So we can go with fillets. So fillet means I can select this edge is where fillet comes. Done. Or I want a fillet every I want fillet here, here. Yeah, that's enough. We can't do the fillet here. Okay. Here, here. Mm, it's showing due to this. So fillet is that option. Then you have chamfer option. Chamfer means we give a cut there. See, it looks good. So I give same chamfer here also. Okay. So that's what happened. Now I'll show you one more part in the SolidWorks. One more section. Like we have many options here. Like if I go uh, like I'll show you revolve. This picture is not for revolving, but I'll show you just to revolve. Revolve means you can take an edge. Okay, sorry. Uh, revolve means, of course, I'll show you in another drawing. If you have a right plane again, I have a circle there which has 20 mm, which is 50 mm from far from this, and these are vertical. So it's now black. Now I can revolve. Before revolve, I need a reference line. For that, I take sketch again. And I take this plane, sketch, center point, done. Exit sketch. I can take revolve. This line is already selected. I need to give this. Hmm, I draw it again. I'm showing these features because it can be used wherever you need. Okay. Now sketch. The plain, just plain sketch again. Hindi. Okay. Sorry. Mm, Here, like you could see that I gave 40 and I now selected coincident means I zero. So it's contradicting. Both dimensions are contradicting. So it's showing error. Okay. I I understood the mistake. Vertical. Done. Revolve. Oh my god. Mm, Sorry. I did in the wrong direction. Sorry guys, sorry. This plane sketch here. 10, maybe 10, 20. I think that problem is 20. Each time I'm giving 20, 40 again. Okay. Hope it works this time. This contour, this line. See? So it revolves 360-degree. Like we have a tube here. But when we draw, we may need not require this 360-degree. We can go to 180, this much. If you want symmetry here, you can give this like this, again 180 or 270 or whichever angle you like, 97 or whichever angle you like, you can give. So this is a feature revolve. Uh, then sweep means like if you have a um, line that I will show. For that means if you have a line, you can sweep it through that line. I'll show you later. Before that, I let me complete the assembly part. Then I will show you again. So before I go to assembly, this plane is like we can delete unwanted unwanted features coming here. So it will be clean. So it's now ready. Yesterday I didn't show you how to save. Here we have save option. We can give as a base 2 When you're saving, you can see here. I will show you again. Seriously. Here we are saving it as SolidWorks part. But like when you will be dealing with design, you will know that sometimes I will be using SolidWorks. The other guy in my team will be using different softwares. So you can save it in any like softwares. Like yesterday, I showed you different softwares are there. Katia, we have Cryo, then Step File. So there are many like softwares available. So we can save it in like any like option so that the other person can also access it. Or you can save it as IGS. It's like what to say, global standard um, unit, like what to say, like global standard type in which we used to save a drawing, or step file as step file. Like when you are interacting with this design people, they will be like asking you in, can you share me the step file, or can you share me 3D XML file, like that. It will, or can you share me IGS file. So if you are submitting any projects, they will ask as IGS or a step file, as because like you will be drawing in different software, or the person who is checking, or the other person will be using different software or different version of the software. So it's better if you are sharing this format. So here, let it be SolidWorks. So now my the base 2 is saved. So now I want assembly. Click home here. I take assembly. So I'm just showing basics of so every like I'm going very fast. Sorry for that. I'm just touching every points, like most of the points, not every points. I'm giving a brief of every section so that later you can go through this. You can like learn more. You can go to YouTube. You can, everything is available in YouTube. You can go through the YouTube, or if you want like help from me, of course you can connect with me, no problem. I'm like anytime you can just ping me in WhatsApp, or you can even call me, no issue. If I'm like, if I'm meeting in some meeting, or if I can't attend the call, like I may not attend the call, but I'll try to give a call back, or um, I will try to message back you in WhatsApp, no issue. You can call me at any time if you have any doubt. Sure. Now this is how assembly window will be looking. So here we click insert components, and we select browse. So uh, before today's session, I just took time to draw some. There is no assembly like picture available with me. I just took just like idea, and like designed a track for this, and a shaft, a symbol shaft and symbol track. So I take this like you click like first thing when you are going for assembly is you browse here, select track, or the drawing which has to be fixed, because you will uh, like in assembly we are inserting many parts. So one part should be fixed. With respect, like in drawing, we used origin to fix the drawing. Here in assembly, of course, there is origin, but here we can like we will fix one part. Then with respect to that part, we will arrange all other part. That's how we do the assembly. So here my base or what here don't go with the name. Here my like fixed part is track. I go with track. So I can click anywhere, it will be fixed there. So I don't I want it to be in origin. So I just take my mouse from the screen and click tick here. So it's now fixed. I can't move it. Now again, I need that base. Insert a new component. Since we just did the drawing few seconds ago, it's showing the base is available here. When we click here, the base is like it's ready. Now I can move it. Now for the second part, you should not directly click on the tick mark because it will be fixed to this origin. It will be fixed here. We need not to like we need to be on this track. So like you click anywhere in the screen, so it's now movable. And I had my one of my shaft here. Mm, yeah, shaft. Yeah, let it be here. It will be also moving because it's not fixed. So similar here we do mating, different types of mate uh, by which we can assemble these parts. So this should come like this, like it should be on this track. So what should we like what we'll do, we can give this and this we click on like we press control and we select this two planes and click mate here. It will be asking like different coincident, parallel. uh I give as coincident because I need to, like it to be touch. Yeah, still coincident means if you could like you'll see still it's moving, but I gave coincident, but here you can see that it will not move this in this direction because this plane and this plane are now coincident. In that coincident it can go anywhere, it can go like this anywhere, but it will be like this only. It won't go like this. That is coincident. Now I have to give this surface and this surface as coincident. Now it's on track. See, now it's moving like it's on track. And I need this shaft in this circle. So what I do, I click this and this. So it's like when I selected two faces, it's showing different options: parallel, perpendicular, tangent, concentric. Like when we select two cylindrical area, of course the first the most like mostly used option is concentric. So it's showing are you going with concentric feature? Yes. Still it's not fixed. See, I can move. So it's underdefined, so I go with I will keep this here in this edge. And for that I can give this and this plane concentric, sorry, not concentric, coincident, sorry. Now it's fixed. This is fixed, this is not fixed. This also you can give it as, if I give coincident, it like some part will be coming outside. So there are many other features. I won't go through that uh, because it will be a little confusing. You can explore many mating options. You have mechanical, advanced. If I had time, like it won't. It will take one more session, one more day session to explain because you must be thorough till now. Then only if I like go into mechanical or advanced mating feature, you can understand it more easily. So here I go, I select this face, and not coincident. I don't want coincident. I want like this mate. Oh, sorry. Mm, Mate feature this this. I can give it a distance. Like I can give it as 12 mm. It's now this surface and this surface is 12 mm difference apart. So now it's fixed. So it's close. So it's it's now a fixed part. Still, you will find it as underdefined because like this shaft can be rotated. I think if you can see, this shaft can be rotated. Okay, so to fix that shaft, you need if you have one edge or here there is no option to fix the shaft because you can't give like any features. Like you can just go and try to fix it. That's all. But there is no other feature you can give to fix the shaft here. If you have any other any other features in this shaft, like if you have any um, rectangular part or like that face, you can fix it. Else, it's difficult to fix. So see, that's the only reason it's showing under defense, or else it's done. And now I have fixed this shaft into it. Now I want to move this. So we can in this mate, we can like suppress this mate. So this feature is now gone. Which feature? The feature which fixed this and this surface is now gone. It's now they're not there. So that's why we can move it. But the shaft feature is there. Shaft is like 12 mm apart from this surface. That feature is there because that is still on. But still, this is not on. This is suppressed. Again, if you want to unsuppress, it will be returning back to this position. So that's a feature in assembly. Uh, Before going to I will introduce some more features in parts which will be useful. If you have any doubt, please you can ask. It's very like we have very less number of audience, so you can ask, no issue. If each of you have any doubts, I can clear it. Yesterday I didn't show you how to uh, I'll give the link to the site from where you can uh, get the uh, SolidWorks cracked file. I won't suggest this, but you can, if you want, you can go with this. This I'll share this link in the chat. You will find the procedure to install in this chat itself. I think it's available in the chat. You have a drawing, you have a video available how to uh, download that. I mean, how not how to download, how to install that cracked file. I won't suggest, but it's the only option as a student to get SolidWorks. All good. I believe if you don't have any doubt. So the like Ardra has given me some more time, so we can explore some more features in design. I'll show you some more features. These all features are simple features. You can just go through it. Uh, Sketch, right plane, rectangle. I give this 100. This 100. And 10. So I want like more circles in a pattern way. For that, we can use linear pattern option. When I click here, it will be asking x-axis. How many patterns do you need? Like I need 5 in this direction, and I need 5 here. Pattern is this is the pattern I need here. Here also, so not 10 mm. I'll go to 20. So at 20 mm difference, I have 5 different patterns. So here also I give 20. And it's showing blue means it's not fixed. You can like you can do this. So for that we just give first and last 80. This and this 80, and still okay. This and this vertical. Like now it's like or if we didn't know about this feature, you have to draw all the circles. So never go with uh, tough works. Go with simple works. uh, Easy steps we have. Other option is then, but you forgot to. Oh, sorry. Okay, I'll and now I go with features, extrude something. Then I draw. I'm going to draw the same draw like same pattern drawing, but in a different approach. This 10, this. extrude cut. It's now there. I want like the holes here and here. Here for that, like in features also we have multiple options like linear pattern. You can give the direction, numbers 5, 20, then here in this direction, second direction. If you want just line means you can stick with one direction and tick. Here they will be asking what is a feature. You click here and you just go select this hole. So here it since now we have selected one hole only. Here we have like given one like number of instances one, so it will be showing one row only. If you are giving two, it will be showing two rows. When we will go with 5 again. Pattern is ready. You can do wonders using patterns and all. Other feature is like when you are drawing a part, I'll conclude this design within 5 minutes. Then I will explain some more. Apart from design, I will explain this little bit and I will conclude the session. You will be using holes like what to say, standard holes to put nut, bolt, and everything. For that, sketch. We have hole wizard available. You can click here. We have standard holes like different standards available like NSNC, ISO with ISO or metric, NG metric, hexagon bolt. There are standards available. By giving this, we can select which is the which is the like dimension we need to go to M6. Then it will be like next process is like we have different hole like shapes of hole type like we have counter bore hole, we have counter sink hole without anything, just a hole. Like that, we have different holes available. Now we should select a position here. We can click here at the center. Done. See, we have a hole like it's a standard hole. When we are drawing like um, drawing for a project, like we don't want to design a new screw and a new nut and bolt. We go with the common nut and bolt available in the market, and we just need a plate and we need a like we need a hole for that standard nut and bolt. So for that we can take this whole option here, and there are all features available. uh then okay, one more feature, not feature, like when doing projects, you will be you like or this is a draw a design, like I gave this design to you, I send you through mail or in some manner I gave through pen drive or any other manner. Now you don't know the dimension, like you want to measure this dimension, like what is the length. So how can you can't, like you can't get a scale and measure from the screen. So here we have, or you have to go to the drawing and like which drawing comes the like which is the drawing, and we have to okay, this is the distance. Okay, okay. You have to understand that, but always draw like going for the sketch won't be helpful. So there should be one option where you should where with which we can measure the drawing, the parts. So here we have evaluate option. Here in evaluation, like don't go like with like you first day itself, don't try to learn every like options you are seeing on the screen. Go for the basic which I showed you. After understanding this, after you can draw, like you are like you are feeling that I can draw with the features available, then you go, like then you improve, then you explore new features, like that you improve your knowledge in the SolidWorks. So here we can measure, we click measure, then this surface, this surface is showing us 160 meters, yes. Or I want area, I click the surface, it's showing this is the area and this is a perimeter. I want this. You can't get area of this with simple calculations. So, but using SolidWorks, it's very easy. Perimeter available, radius 30. Another feature is you need like weight of this body, because like if you are doing a project, there will be like they will be telling this is a weight limit we need. So like what else you can do, like you have to calculate the volume, and using the density you have to do the calculation to calculate the weight, or else you have to come like what to say, you have to make this model in real, like using the real materials, and measure it. So that's all, like if any issue, like if it's not satisfying the rules of the project or the competition, you have to make it again. So it's a like waste of time, waste of like material, waste of money and everything. So before going to that process itself, we can calculate. For that calculation, we have one that, as I like mentioned before, you can calculate using, you can calculate the volume, then using density you have to get the weight. Assume this drawing, how will you calculate the volume? It's not a simple task. So for that, here we have mass property. Simple, just one click, I got the mass in grams. I got the volume. This density is of this material we selected, plain carbon steel. If you change the material, this density will change. This mass will also change. Okay. Here you have surface area, the total surface area. Then here you have center of mass. So these all are the basic, very basic features you should know when you start learning SolidWorks. So here I'm concluding drawing. So before I conclude, uh, as I mentioned yesterday at last I was telling you guys that I'll show like during my introduction I told you that I am a certified SolidWorks professional. You can also get certified in SolidWorks, but I'm not saying that you directly go like it's an exam. You have to design and you have to like give answers as per the question. So once you have a like the passing mark is about 80%. So it's like if I remember, it's the exam was for 360 marks, and the passing percentage was 320 or like that. So you have to get that 320 marks to get certified, or else it's gone. One option is you can uh, go in Google and go and search CSWP, mechanical design. So take exam. So you can purchase uh, using 10,000 rupees. Again, SolidWorks is an expensive software. So You need to purchase give by giving this amount uh, to get this exam. So here, like you can go through the syllabus. It means the syllabus available. Like these all are the syllabus coming. So most of the part, like out of this syllabus, I have explained to you. Assembly, this mass properties, which I showed you, uh, and some of the features like it need time. Like we can't learn in this 2 day sessions. It will take time, and it will definitely take your practice. It's not just a class you take, you have to practice. Like each time you practice you can improve a lot. That's that's the best way to learn. Here, like sketch we have learned, a shell we have learned, a whole wizard, equation. Like it's a good option, but it will make you confusing at present. Mirror, dimensions, basic features, you can go through here. Then of course you can take a sample CSWP test for free, but you have to pay for the original exam. But if you want, there's always a but. uh, you can take this exam for free. For that, you must take part in a competition conducted by Dassault Systems that I'll show you. Let it be little suspense for 2 3 seconds. Sorry, this is starting. So today we just completed this I will just go through. So there is an event called Akruti, uh, through which they provide not just CSWP. There are many certifications. I will show you. Uh, you can. There are like you have sheet metal, welding, weldment, drawing tools. This is solid CSWP only, like associate level, then professional level. Surfacing, additive manufacturing, sustainable design. So there are multiple what to say exams. These all are separate exams. You have to pass in each exam to get certified in this. So you will get an opportunity to write the exam. They won't give you the certification. You have to you have to um, pass, get the pass mark. They will just give you a voucher free of cost. That's the only thing they will give. You can attempt the exam for free. Then if you get the passing mark, you get certified. You are also a like what to say certified SolidWorks professional. But that for that you need practice. It's not a 1 day task. If you can sit daily, if you can learn daily, you can take 1 or 2 months. Still there are like I have many of my friends who can't even get the pass mark after 2 months of studying practicing daily. So of course it's like at last exam means it's a mixture of luck and practice. You have to practice a lot. I will share this link also in the chat. Okay. So one apart from the agenda that Ardra and the coordinator gave me, I'm going little bit further. So if you are if you are interested in designing, SolidWorks is one option. There are other softwares available in the market. As I showed you that day, uh, we have Katia. it's similar to SolidWorks. Means you have to pay to get it. Uh, so I won't suggest you that. These all are like industry softwares. I won't suggest these softwares at the starting. You learn like software like SolidWorks, or I'll show you another software which is called as Fusion 360. So it's compared to SolidWorks and all other softwares. This is a very new software, and this has many features. Like here you can work like here you can work here the Fusion 360 is a cloud based software. So you first thing is you need an internet like to work, because um like this, since it's a cloud based software, you need an internet to work on it. So that's one feature. And like anyone using MacBook here, anyone having MacBook, like please, I'm expecting an answer from you guys. Yes or no? No answers. Okay, I take it as a no, because in my like when I was in college, I had one of my senior who was using MacBook. So the problem with Mac is you can't use all the softwares like SolidWorks. You can't use SolidWorks because you see, I've seen that in the system requirements they are asking Windows software. You can't use Mac. iOS, you can't use SolidWorks in iOS. The all other softwares you can't use in MacBook. Of course, Mac is not for designing. Uh, it's like it's more of like office type or video editing type. Yeah, but if you are like if you love Mac a lot, but if you want to design, you have the software Fusion 360. Like in my knowledge, this is the only software which is support like which supports on Mac. It's only design software which is supports on Mac. Then here you have free trial, and I won't say you to go with free trial. You can search Fusion 360 student version. Yeah, free software for student. You can give your college ID and download this Fusion 360. You can use it for 1 year. After that, you have to renew it. Still, it's free only. Renewal also free only, but you have to renew it. So this is a one of the software you can go and explore. But for me, like I have worked in SolidWorks, I like SolidWorks a lot. So that's all. And again, I'm repeating. I'll give this thank you slide, and I'll give you my number. So if you want to connect with me, you can connect with me in mail, phone number, no issue. This is my WhatsApp number. You can, if you want to connect, if you want to connect with any like design related doubts, I'm ready. And all good. Yesterday's same session. You can ask me anything. Of course, designing CAD is a first step. There are like a vast world beyond this. This is just basic. This the CAD at present world is very basic. There are uh, simulations happening, FEA. So as mechanical engineers, you have FEA, CFD. For electrical engineers, you have of course you can learn simulation where like thermal um, simulations, like if you are using board, or if you're using an electronic systems or electrical system, you should know the thermal properties. You should know the how the temperature travels, how the cooling is done. For that you need to know simulation. You should learn simulation. Before you learn simulation, I would suggest you make your base in SCAD strong. Then you can go to simulation. Of course, like I think you mostly you will be in first year, second year. You can learn CAD here now, and in third year you can explore simulation. Then fourth year you can do projects in simulation. Similar now also you can do projects in parallel. Of course, yeah, that's all. If you have any doubts, please let me know. Similar to yesterday, I expect like yesterday, like after one thing I have to remind is yesterday after the session, Ardra was telling we had about 50 plus registration, but we got yesterday about 1/5 of that registration. I also saw about 14, 15, maximum 14, 15 attendees yesterday. Still today it's reduced to like if you are not taking the coordinators, it's about 10 or 9. But I told her that it's not about the numbers. Like I don't want 100 people listening to the session just like just to be there. If at all, if any one person is there who wants to learn design, if he wants an introduction about SolidWorks, so he want to get an introduction about Fusion 360 or any other software which I know, I'm happy to like share my knowledge. I'm not telling that I am like expert in this. There are many parts like in the SolidWorks itself where I am not much aware. Still I'm learning. So but the knowledge I'm having, I'm happy to share. And like anytime, any number, even if it's one, like in my college I have like helped many of my friends just sitting one on like one by one on one, see like explaining each and every sections. So this is not a big deal for me if I have having just if one kind like audience, or if I'm having too much, I'm happy. Like if you are having too much means okay, there are like many people who are willing to learn. And I'm saying that like if they are learning in any other way, yeah, it's good. But if they are not learning the design, I'm saying it's a huge mistake they are making during their studies. Because you will understand once you complete the fourth year, you will understand that during like what all things you could have done during your 4 years. So try to learn, try to acquire skills uh, during this 4 years. Like you won't get this time again in your life. So try to learn. I think like most of you are from CET. You have like best faculties in the state. If you can take from state, you have the best faculties. You take help from them. You learn, not just design anything. But after 4 years, you shouldn't be just a BTech. Like we could say there are many number of BTech graduates each year. I would say that you should be not among them, just a BTech. Try to acquire knowledge, try to acquire skills, and after this graduation, nobody will like look into your degree. If you have skills, any company or any people. You at present startups are there waiting for skilled people. They don't want a BTech graduate or MTech graduate or PhD person there. They want a skill, and they want people who are willing to learn. So at present, if you could take 9 people, these are the people who are willing to learn. The coordinator told me that they are not providing the certificates. Certificate is nothing. The certificates are just nothing. If you can show a person that I'm skilled in this software, there is no requirement of certification. If like, you can take the certification later, but if you are skilled, if you are confident that I'm skilled, that's enough to show a person. So that's all my two coordinators.
Thank you all. Thank you for being a part of our SolveWork workshop. I would like to remind you to kindly provide the feedback in the feedback form given in the chat box. I also want to inform you that recording of the session will be available on our official website. Once again, I extend my deepest gratitude to Mr. Anjan Kanakillam for his exceptional guidance and expertise throughout this workshop. Your contributions have made a lasting impact on all of us, and we are truly grateful for the knowledge and skills we have gained under your mentorship. Thank you all for your dedication, participation, and enthusiasm. Keep exploring SolidWorks, applying the technique you have learned, and pushing the boundaries of the creativity. Thank you all.
Thank you all.